I'm Abishek Shenoy from Simon Langton Grammar School for Boys, and I am a member of the LUCID project. So LUCID is actually a device of 5 chips in an open cube. And as you can see, it's an open cube, so there's 1 at the bottom and 4 on the sides. This is on the Detector satellite, DS1. Anyone who wants to track it out can just use the satellite ID. It's a part of the Space Environment Suite, which means there's also other payloads, including one from Imperial and one from the Rutherford Appleton Laboratory. The chip itself captures a snapshot of the particles in space, so you can analyze the data as in like a camera, like my camera showed you before. So we collect data every 2 days out of the 8 days that we get of the time period from SSTL, and this is uploaded to a server which all the students can access. This is 30 to 300 data files per run, so as you can imagine, it's a lot of data files. And analysing this takes a lot of time and also effort. 50 to 200 frames per data file. So again, each of those frames is the snapshot of an image at a specific time and a specific position in space. The format I'm going to show you in a bit is the XYZ format. And we collect the information which we collect is data file ID, the geolocation, and timestamp. And you can use this for various experiments. For example, if you want to track at a certain time, I don't know, so a year ago, maybe a couple of weeks before today, you can look back at the data and view what type of data you're getting at that point, what kind of radiation. Or you can go to a solar eclipse or a lunar eclipse, and then you can see what kind of data you might get at that time, depending on where LUCID is in the position. The XYZ format is the X coordinate and the Y coordinate on the chip, and then the C is the energy value. As you can see, this is a beta and there's a gallons, and as you can notice by the particle tracks they make. And each particle has its own identity track, I guess, more like a unique one. Muons are like really straight and go straight through the chip with really high energy. Protons, more like muons, but shorter. And there's beta alphas, which are much bigger and blobbier. As you can see, the amount of data already collected is about 6,000 data files in a time period of about 1.5 years. If you imagine the world map in front of the latitude and longitude, that is the data file we collect at a specific spot at the given time. And I think this is a big achievement for LUCID. The LUCID Dashboard is a software used for analysing this program, used for analysing data and viewing it in general. You can filter out different particles by their energy values using the slider, and then you can track you can view different protons, muons, or even alpha, beta, gammas, depending on their energies. And as you can see, there's detects as a proton, I think. Yes, but that could easily be a muon. So that's improvement that could be done on the analysis algorithms. We can, apart from that, we get the timestamp and the geolocation of the set, and you can actually geocode it to a specific address. Well, of course, LUCID in space, so it's directly above Stonewall's house, I guess, on the street. With the data files, you can view it individually, and you can search out for a specific location, so postal location above your house, for example. Of course, we don't have that many data files. 6,000 over the Earth is actually quite a small amount. But the important data is actually how you can use it, and I think how we can do later about that. A part of this is radiation map. You can view the South Atlantic anomaly. This is the thing that Michael Campbell showed you. This is where how much data is the highest energy level in space due to the magnetic field getting really close to the Earth. And as LUCID posits, we can get different loads of data, which is high energy particles. As I showed before, the frames with the muons, protons rather, are actually from South Atlantic anomaly. And as I said, it's a really high energy position. Again, you can search the address, you can view different times, data files, you can even track LUCID in real time, that's a very good feature. And 3D Tracker, I intend to get a radiation map on this it's going to require some work. But the radiation map will eventually be on over the 3D globe, and then you can view it as a 3D thing instead of a 2D, which more like confuses people with thinking it's on Earth, which is actually right. Now, things to do we can do later with this is with the data that we get is use it for space weather, so that astronauts can use it. As you can see, that is the radiation map we've actually created, the latest one, and we can investigate the South Atlantic anomaly using this data. We can find different particles, muons, and occasionally we get the others classification, which you don't know what it is, but you can always investigate it to just try and find out what kind of particle will give you that trap on Earth. And then we can use 3D particle tracking algorithm or program using computing to understand how it is in terms of the 5 chips we have. So if it goes through 2 chips at once, you might be able to find out when it hit both chips at once, so you know it's a single particle that's gone through both the chips. So that means it's a really high energy. And the main thing we need to do is improve the particle track analysis using for TAPAS. Again, Laura and Jacob will come to you about that. And we'll be collaborating with CERN and Tim Bix to carry out more research.